we're going to go through some of the material in chapter 2. And this is where we get into kind of fitting science into the larger realm of our world and starting to think about really how it's done. So I'm going to share the PowerPoint slides from chapter 2 concepts. These are on Canvas as well. Get slideshow going. Okay, so to start off, I want you to go ahead and write down in your notes 3 things that you think are true or things you believe. Anything, sky is blue. Most fire alarms are false alarms. Whatever you want, just write 3 things down. And you can pause this while you do it so I can make the video shorter. So just pause, write. Okay, you're back. Now I want to know, how do you know these things? I mean, really think about it. Where did this information come from? Why do you think it's true? Did somebody tell you? Did you experience it yourself? Really think about that. And there are a lot of things we observe or we experience ourselves. And if that's how you know something, go ahead and write experience next to that thing that you know. And it has to be firsthand knowledge. You were there, you experienced it. Then go through and see if there's anything you believe or you believe to be true because you learned it somewhere. Somebody told you, maybe a parent or a teacher, or you saw something on the news, or you saw something in your feed and you're like, saw a headline and you're going, oh my gosh, I can't believe that's true. But you do believe it's true. Now that's what we're going to call authority. If you have something that's essentially secondhand knowledge, somebody told you and you believe them, we're going to call that knowing from authority. Now, it could obviously be an expert. You believe the person because you think they know more than you do, or they're an expert in the field. But it could also just be your roommate who says, hey, it's snowing outside. Did you notice? And you haven't looked out the window and you go, oh my gosh. You believe her because she was outside. It's secondhand knowledge, but you trust her. That's authority. So experience is going to be firsthand, and we use it all the time, right? And then authority, I'm skipping that other one just for a sec, is if it's secondhand. And again, if we listen to the news and they tell us something, even if they say, researchers have found that blah, 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 and I go, oh my goodness, researchers have found, it must be true. That's still something I know based on authority. Now for intuition, your book calls it intuition, I'm going to call it logic, same thing. That's when we believe something to be true because we've kind of put the pieces together. Think about when you put 2 and 2 together, you come up with new information. So let's say I know that a certain model of car has gotten a lot of awards. My friend has one of these cars and they think it's great. And I looked online and the car is in my price range. So I decide this is the perfect car for me to buy. Well, that would be logic because I'm taking different pieces of information, putting them together and coming up with my new conclusion. That's the perfect car for me. So of all the 3 things you wrote down, you should be able to fit your things into one of these 3 ways. And probably it's experience authority more than anything else. Now we use all of these ways all day, every day to make decisions. And where should I go for lunch? What classes should I take? What time do I have to leave to get to class? Where am I going to find parking this time of day? And they work for us really well. Now, what I want you to appreciate is science is just a 4th way of knowing. It's another way of knowing. So I have a handout. It should be on Canvas as well. Let me change what I'm sharing with you so you can see the handout. And you can go ahead, hopefully you're seeing that now, and pause the video. You should be able to see these 5 examples. And I want you to label the 5 examples as an example of experience, logic, authority, or science. So go ahead, pause, and do this handout or get it from Canvas and do it. Okay, I'll trust you did it. My answers to these, let's see, the first one would be experience, okay? The second one would quite obviously be authority. I believe the mechanic. The third one, look, I'm putting a few pieces of information together. So that's going to be logic. And the fourth one, again, I'm putting 2 things I know and coming up with a new conclusion. That's logic. Now the 5th one usually throws people a little bit. They're not sure where to go with it. I am going to say the 5th one is science. So we have to talk about, well, what is it that makes using science? Science is, and here's my answer. To be using science as a way of knowing, you don't have to be the person who collected the data, published it, etc. You don't have to be the actual researcher. But you have to do more than simply seeing a headline, researchers found that puppies decrease blood pressure, and go, oh my goodness, that's so cool, puppies decrease blood pressure. Now, what way of knowing have I just used if I just read it and believe it? Or I hear it on the news, or I see it on a commercial and I believe it? That's just authority, right? And we often actually do that quite a lot with scientific research. We just see it and we uncritically accept it, and that's a way of knowing that we call authority. But you could use science, and for you to be using science, what I would say you need to do is you have to critically think about what's being presented. So you hear something on the news, puppies decrease blood pressure, and you ask yourself, I wonder how they collected that data. Was it an experiment? Was it a correlational? How did they measure their blood pressure? What kind of puppies are they talking about? How many people did they test? So if you're wondering about sort of things about the design and you're a little cautious or critical or skeptical, and you answer your questions sufficiently and you go, I think they did a pretty good job. I believe it, puppies decrease blood pressure. Well, then I could say, yes, you're using science. All right, let's go back to our slides here. Okay. It's being slow on me. Okay, I'm going to close that down. Sorry. Okay, I think you're seeing the slides now. So, okay, so that's as far as we got in class, if you're the class that had the fire alarm, and we'll keep going from here. Now, what I want to, posit to you is that I think science is better than these other ways of knowing. It's not the only way, and it takes a lot of time and effort, but it has some cool things that the other ways don't have. So there are definitely weaknesses in any of them. So if we look at the following, say experience, I met somebody and they were so rude. Maybe they're an awful person. So this is what I believe based on my experience, right? You can't tell me I'm wrong because I was there. Well, what could be wrong with that? Maybe this is a perfectly lovely person and I came to the wrong conclusion. Why might that be? Well, maybe I caught him on a bad day, right? Maybe something else was going on. I have one experience. Maybe I need to take more data, have more observations. So experience can lead us astray. We say, hey, seeing is believing, but we also know our senses can deceive us, right? So we have to be careful. Our one experience may not be typical or accurate. What about logic? This is something I believed the other night because we had snow days in Knoxville, and I know UT almost never closes, but I also knew the roads were still icy. And so I was pretty sure there was going to be a 2-hour delay on Wednesday morning. I was right. So I had put two and two together, two things I knew, and I came up with a logical conclusion. I happened to be right. Now, as you can appreciate though, humans make mistakes in logic all the time. And if you've never even had a class in logic, you'll just know, well, here's an example. Let's see. All crows are black. That's pretty much true. The crows, they're all black. And if I'm looking at a bird right now and he's black, and I go, therefore that is a crow. Well, it might be, but it might not be, right? Because I've made an actual error in how I came up with that. My logical process was erred. The first two premises were correct, but my logical conclusion, there's a mistake in there. And we do that all the time. We're not perfect at our logic. What about authority? Well, obviously people who tell you stuff and you believe it, they could be wrong. And it may be they just don't know any better. Or it may be they have an agenda. Or it may be, they're telling you they only know part of the truth, not the whole truth. There are lots of reasons. You can see this example. Politicians come out of a meeting and they're saying two different things. And one of those is true. But who do you believe? And you're probably thinking like, well, you know, what's their history of being truthful, or what do they get out of being truthful or not being truthful? So obviously, authorities can deceive us intentionally or unintentionally. What about science? Is science ever wrong? Yeah, of course, it gets it wrong. But the thing that science has that the other ways don't have, oh, we'll get back to this, is there's a self-correcting mechanism. So when science does get it wrong, we figure that out eventually. Sometimes sooner than later, we hope. We figure it out in two ways. We have peer review, so other scientists have to really look through your work carefully before it gets published. But even that, people fall through the cracks and things don't get published. But there's also replication. So you take data, you got to do it again, try it again. Other people try it and see if their data come out the same. That's probably the best method of figuring out if we're right or wrong. Now, you know, I said I'm a big fan of science. Does it answer all questions? No. Is it the best method? Sometimes, but it takes a lot of time and money. So if you want to look at this list, are there certain questions that you would want to use science to answer and others where it wouldn't necessarily be important? Go ahead and pause the video so we won't use up a lot of tape here. Make your choices. Okay, hopefully you made your choices. Here's what I put down as things where I think I want some good data. I want science to tackle these questions. The other ones, not so important. I don't want to spend the time or the money or the effort to use science, or they may be questions that science can't even answer. What electives should you take? I don't know. What fits your schedule? You know, where to go on vacation? Well, there's lots of places that would be great for vacation. You don't need to throw science at that kind of question. But the other ones are pretty important, and I would rather use a scientific method to answer them. All right, so here's some of the ways that science compares to other ways of knowing, because those other ways are often part of science. So we use observation, we use experience in science, but it's systematic. It's not like a one-off or an anecdote from here or there. We use controlled, systematic observations. We obviously use logic. There's a lot of logic and thinking and rational thinking in the scientific process. Just trying to think about what kind of experimental controls we have to use. That's a lot of logic. And authority happens a lot. People will, when they're peer reviewing papers, if they know it's from someone who's an expert in the field, maybe they're not as critical. It just takes, I put vigilance down there because we have to remember that it's okay to questioning other researchers is a part of this field. And sometimes in practice, because we're human, we get a little nervous, or we just assume, oh, they know what they're doing, it must be right. So you look at a title of the paper and you go, wow. You look at the abstract, wow, what great data. And then we fail to go in and actually ask those critical questions about, well, how did they collect the data? How did they come to their conclusions? So scientists just have to be real careful not to fall back on that, oh yeah, Bob, he knows what he's doing, what great data he has. You have to look at the data every time. Okay. So in systematic observations, you know, I said a lot of times in our personal life, we may have our own experiences and we just have a couple of, you know, things that happen to us and we make conclusions of that. We can't do that in science. So look at this. Here's a claim, a question. Does volunteering keep you young? Well, collect some data. It says 76% of people who volunteer feel younger than their age. So the question now, and chapter 2 covers this kind of example. Who are we missing? Like 76% of the people, we have a certain kind of person, people who volunteer. Like I assume they're older people that volunteer. And that's interesting, but we need to compare them to who. Maybe we need to compare them. What if people that are elderly and don't volunteer also feel younger than their age? We would want to know that. So there's some missing groups here. There's the people that don't volunteer. And then there's the people that feel something else. And there's only 3 possibilities. You either feel your age, feel younger, or feel older. So look at all those missing groups. I would say the most important group is what percent of people who don't volunteer also say they feel younger than their age? That would be interesting. And so the 76% on its own doesn't really mean a lot unless you have that comparison group. Okay, here's another one. I want you to do this one on your own. 70% of people who survived air crashes read the safety manual. Okay, we got some missing groups here, and I'll tell you, there's 3 missing groups. Now, one of the groups we could actually fill in. So I want you to pause the video in a second and draw yourself a table with 4 groups. One is people who survived, who read the manual. Now, what are the other 3 groups? And for one of them, you can fill in the data because it's the remainder from the 70. So pause the video, draw a little table, and see how you do. Seriously, pause the video. Okay, I hope you did it. Here's the table. Right? So of those who survived, we asked them, 70% said, yeah, I read the manual before takeoff. 30% said no, because that's who's left over. What about the people that didn't make it, right? Maybe 70% of them read the manual. Maybe 100% of them read the manual. I don't know. But there's some really important comparison groups missing for us to put the 70% in some kind of context. Okay. All right. Now, before next class, you have some things to do. One is there's a PsycInfo quiz up. It's pretty easy. It tells you what to do. Just open and do it. Then I have the directed notes up. So you need to submit them to the email or bring an extra copy. This time I want to give you some more feedback. So if you're going to bring a hard copy to class, I actually need you to bring 2 copies so I can have one and you can have one. So it might be easier to just send it to directed notes. Now, if you write your notes, which I love when people handwrite notes, you could just take a picture of it with your phone and email the picture to directed notes. That would work okay. All right, then Chapter 2 quiz. Then we're going to do this journal to journalism thing. And I'll send you a separate email, just make sure this is there. But I want you to find some kind of newsy item about science, anything, online. And if you can, print it out somehow or have it tagged so you can have your laptop or tablet in class and get to it. But then find the article it was based on. Okay? Now I'm going to give you an example. We'll go ahead. Hopefully this will all share. Hope you're seeing all this. But that link took me to a CNN page in their health page. And here it's no more than 6 teaspoons of sugar a day for kids. So here's my headline. And it talks about a study. Now, fortunately, a lot of times they'll have a link to the study. Although, watch what happens. So I'm going to go, oh, I want to find that study that this is based on. Actually, let me go down here. Here it says published in the journal Circulation. So I click the link. And let me make sure. I'm going to change the share to make sure you're seeing this. Because I think you're on the other. Let's see. Here we go. Okay, now you should be seeing this. The link from my PowerPoint took me here to the CNN page, an article about sugar in kids. Then I clicked the link here for the study that this article is based on. And I opened up this. And look, it says download PDF. Now, I doubt it's going to let me. Let's find out. Because I'm on campus, it let me download it for free because it knows that I'm on UT's wireless and the library has a subscription. So I was able to get it. If you're off campus, it'll probably make you log in. So look at this. Bada boom. Here is the article that it was based on. Now, what I need you all to do is have access to the news item, the journalism, whatever it is, off a website, from the newspaper, wherever you find it. But the journalism science writing piece, and then the PDF of the actual scientific article that is the basis. And you'll often find maybe multiple things in a news item. Just pick one thing and bring it with you. But we're going to use it in class for an assignment next class. So I think that wraps up what we need to do right now. It's long enough. The video's gone long enough. So do all those things, and I'll see you on email as well, just to make sure it's clear what you have to have done. And cool, in chapter 2, get to those directed notes because there is a bunch of information that we got to cover. It's a pretty dense chapter. All right, see you all next time.